that may contain some sales pitches. Then text detection applications would be content retrieval or filtering, character recognition, or text translation for international sales. Today, I'm very pleased to report that our IT text detector, actually, which is phenomenal. It is far more accurate than before. It works like magic. But don't worry, I'm not going to introduce iPhone 6 today. Although I read Steve Jobs' presentation textbook last night. This is actually recommended. One of my friends wrote this book. It's very useful. So today I'm just introduce a text detector. So it can detect not only regular solid text, but also transparent text, like this. And after we detect transparent text, we can even recover the background of this text. So this is my outline. After talking about text detection overview, so we're going to review some current methods in academia. Then I will introduce RIT's approach. So in academic area, text detection has been a long-term research, starting from a traditional scan OCR, which tries to scan documents by flatbed scanner. But today's text detection is different. Because of the popularity of imaging devices such as mobile cameras, the images might include illumination variations, perspective distortion, then the text would be shorter. Then the product images have two different roles, two different purposes. But depending on the purpose, the role of text is different. So the first purpose is to show sales pitches. Of course, text is necessary. But if the purpose is to show a product variation as e-commerce, this is an example of a product list. You don't want to have sales pitches. This is just to show a variation of products. Then another example is that we are also using what we call non-printing images. So those images are used when the product photo is not available, although the product itself has been already released, or we are taking just pre-orders. Then those images are supposed to be updated when the images get available. But we need to detect those images first. Then the problem is that those images are not always given by Rakuten. So since we are having a e-marketplace model, so those images could be provided by our merchants. So it could be arbitrary. So we don't know what type of images they're going to use beforehand. So it's kind of difficult to detect. Then in summary, so text detection for product images needs to be more accurate than before. Then, of course, so it needs to be processed much faster. So we're going to review some current methods in academia. Then the current methods can be divided into three types: text-based, region-based, and hybrids. I'm going to describe these methods. The first type is called text-based method. It tries to find spatial texture by scanning a window across the image by using classifiers based on machine learning techniques. But there are problems. They are scale rotation invariant. Then the computational cost is high. The second type is called region-based. It tries to find local features based on edge detection or color clustering, followed by component analysis and so on. But again, the problem is it may contain some false candidates. So therefore, the third type is called a hybrid of these two methods. It's having a lot of attention these days to avoid these problems. And based on region-based, so it's going to classify detected regions by using some machine learning techniques. But even with these latest methods, of course, there are some problems. Otherwise, we don't have any work. So we are looking at the following two problems: character word annotation or transparent text. The first problem is a character word annotation. So in order to use machine learning techniques, you need to have annotation data, annotated data. So if it's a character or word level annotations, we need to annotate by hand. Then the human operator needs to place rectangle on characters as accurate as possible. So if one image contains a lot of characters, or if we have a lot of images, the annotation task will be very time-consuming task. Then the second problem is what we are looking at is transparent text, which is more difficult to detect because edges are weak. So I'm going to introduce a solution to solve these problems. So we are working on a character word annotation problem by developing a text image classifier and also working on a transparent text detection. So we are working on image-wise annotation. Compared to character-wise annotation, image-wise annotation is much simpler, just to annotate whether the image contains text or not, very instance. So it's much simpler and then less time-consuming, more efficient. Then, based on this annotation, then when we detected regions are represented by image features, in this case, two image features, F1 and F2, then we're going to cluster those detected regions. Then we're going to look at image-wise annotation result. So for example, when we look at the cluster C1, the red dot represents that the detected regions are appeared in text images in learning dataset. Then the blue one was found in a non-text image. Then we might say that the probability of being text is like 3/4. On the other hand, when we look at the cluster C4, so all of the detected regions were found in a non-text image, so it's kind of very unlikely to be text. So based on this kind of information, so we were able to increase the accuracy. So we compared with a typical previous method, and then the accuracy increase is kind of significant, like 20% in accuracy. Then I'm going to talk about the second project, transparent text detection and its background recovery. So we are trying to solve this problem by adaptive edge detection thresholding. So these are results. Compared with traditional edge detection results like Zobel or fixed threshold canny, our results are better with less noise and weightage is also preserved. Then I'm going to show how we do edge detection. So we're going to measure image complexity as texture strength. So by analyzing image by the image pixel variation in eigenspace, we can get the texture strings individually. So we're going to measure all of the images as input, and then based on this information, we're going to set up different thresholds for different images. Then the overall system is based on the latest hybrid method. Then here is the system flow after having adaptive edge detection. So we're going to get some components using one of the region-based method called stroke width transform, followed by component analysis. Then we're going to get the text detection. Then these are the detected results. We were able to detect transparent text locations. Then after detecting text, we're going to get background recovery. Then I'm going to show how. So transparent text, pixel values of text can be described with this formula. Observing pixel value I is a mixture of background pixel value, in this case O, and a text color T. Then the mixture rate is represented by opacity, gamma, for this case. In other words, transparency. It might not be necessary to 0.5 to 0.5, so it could be varied. Then by estimating these two parameters, if we assume that the texture color T and gamma opacity are uniform in the text. So we can solve this problem. If we have two sets or more data points, different data points, so we can solve these equations by least squares method, since the number of unknown parameters is just 2. So here is an example. Then we, of course, we compared with the previous method, which is called inpainting, that tries to fill text regions as a whole by using a similar surrounding pixel pattern. But theoretically, it's not possible to recover the details. For example, behind K, there's a small hole here, but it's not able to recover the whole. But our method was able to recover the tiny details as well. So we can say that it works like magic. Boy, we patented. Then the detail will be presented at International Conference, Asian Conference of Pattern Recognition next month. Thank you for your attention.
Good afternoon, everyone. So I'm Keiji Shinda from Rakuten Institute of Technology. So from me, I'd like to share about the technique for building structured data from product description. The paper related to this technique is available on the web, so please refer it if you're interested in this talk. Okay. So we want to create a system that extracts the product information from given text like this. So if we get the text Italian product, this is a fruity red wine that mainly consists of Sangiovese grapes of Tuscany. The system output the type of wine is red, and great variety of wine is Sangiovese, and the region of wine is Italian Tuscany. So we want to create this kind of the system that output this kind of table data from full text. So the reason why we do this is that structured data can play a crucial role for making the Rakuten or attractive service. So if we have the structured data for all products in Rakuten Ichiba, so we can provide a more sophisticated navigation and recommendation. So this is one of the examples of the more sophisticated navigation called passive navigation. So this kind of navigation is provided by the Amazon.com. So this kind of navigation is very useful for online shopping users because user can narrow down the list of products according to the product attributes. So in this case, the user can narrow down the list of wine according to the wine type, wine grape variety, and country of origin, and others. So in order to realize this kind of navigation, so we need structured data. But in Rakuten, the majority of data is not well organized. So we need to construct a structured data from the data we have. So that in Rakuten, so there are tons of product and categories. So it's very difficult to prepare the supervised data manually. So we are trying to solve this problem in unsupervised manner. So you may think that the structured data can be easily induced from the table data in product pages in Rakuten Ichiba. So this idea is very nice, but the number of pages, including the table data, is very small. For example, the ratio of pages including the table data is only 38% in the wine category. So this means the remaining pages consist of full text only. So we need to process a full text to achieve our goal. The technical issue here consists of two. Technical issue is we have two technical issues. The first is how do we know attribute for category, and the second is how do we extract attribute values from full text. For first issue, a key idea is to analyze a large number of table data in Rakuten Ichiba. So by parsing, so some of merchants already provided this kind of semi-structured data on their own pages. So by parsing this table data, so we can grasp what kind of attributes are related to the category. And then we can also catch the attribute values corresponding to attribute names by just simply parsing the data. So this is a this is a automatically constructed product database for wine category. The first line shows the attribute names, and the other shows the attribute values. The characteristics of this database is precision is high, but the coverage is low. Okay. So for the second issue, so we propose the approach based on the distant supervision. So distant supervision is one of the unsupervised methodology. So as I mentioned, we already successfully construct a product database, the small database like this. So we leverage them to extract the product attributes in full text. So at first, we annotate the product attribute in the database to the full text like this. So this is an actual example of the annotated data. So the top sentence is Japanese, and bottom sentence is English, translated sentence in English. So in the first sentence, so we can see that Alsace is annotated as a production area of wine, and in the second sentence, the domain table is annotated as a winery of wine. But the last sentence, the word white in the whitefish is annotated as a type of wine. So this is a long incorrect annotation. So this constructed annotated data is not perfect, but we use this for generating the extraction rule. Okay. So by considering the word surrounding the attribute values, so we try to generate the extraction rule. So this step is actually conducted by a machine learning approach. So this task is very similar with the named entity recognition, which is a famous task in natural language processing. So we took the similar approach. So as training algorithm, so we employ the conditional random field, and as representation of tag, we use the start-end tag model. And as features, we use these information, and they are frequently employed in the task of Japanese named entity recognition. Okay. After the generation, so by applying the generated rule on the new product page, so we can extract the product information like this. So our approach is not only for the region for the wine category, so we can extract the other information like this. Okay. So this is a performance of our system for wine category, wine and shampoo category. The blue line shows the performance when we did not employ the machine learning approach, and red bar shows the performance when we employed the machine learning approach. So from this side, so we can see that the machine learning contribute to improve our system. Okay, so let me show you some a demonstration of our system. Okay, so this is a product description in the wine category. So I gave this sentence to the system. The system reads this Japanese sentence and extract the product information like this. So from this sentence, system output 13% is alcohol, and white is a wine type, and Chardonnay is a grape variety, and Chablis and Bourgogne is a production area, and 720 milliliter is a volume of wine, and winery is a domain long table. So this system is not only for wine. So we can extract the product information for other categories. So this is a list of categories. Our system can extract the product information. So so this is a product description related to the handbag. Okay, so system extract the product this product information. The size is like this, and the brand is saline, and production area is France. The material is leather, and color is a color pink. And in addition to this, so this our approach is not only for Japanese. So this is a sentence written in the French text. So okay. So unfortunately, so I don't understand this sentence, but our system can read this sentence and extract product information like this. So in conclusion, so now RIT try to developing a technique for extracting the product information from full text in Rakuten Ichiba. So our approach is not depending on any category and any language. So the outcome of our technique is useful for providing a more sophisticated services. And so in our paper related to this technique is available on the web. So if you're interested in the technique, so please read it. So that's it from me. Thank you.
Okay, good afternoon. My name is Satoshi Sekine. I'm director of Rakuten Institute of Technology, New York. And yeah, the previous two talks, there is lots of technical terms like machine learning, etc. I hope that I'm not going to do that, and you can keep awake and listen to my talk. So first, I want to talk about the goal. So why we are doing research, and what's the goal we want to do, what we want to achieve. So we want to create this guy. That's our goal. The point is that this guy is not vending machine. This is a person. So from our point of view, Amazon is vending machine. Okay? You want to say, oh, I want to have this. And they show you a list of products and with a price. But if you go there, you go to the supermarket and talking with this kind of guy, it's a human touch. It's fun, entertaining. So that's something we want to create. So we think that what kind of conversation we have with this kind of guy. For example, people might say, like, how was the carrot you got yesterday? And he can say, like, today this fresh tomatoes, lettuce is good. So this is called, this is a technology called recommendation. Or you will take a vacation. The travel agent over there gives good service. So this is a technology called affiliation. Or you are on a diet but like sweet food. And this sweet tomato is good for your health. So this is personalization. Or maybe you will bring some picture like this, and you assume you don't know what it is. I don't know, many people may know. So this is anti-joke. This is image recognition. And wild knowledge can say, like, you can boil it and it's mayonnaise. So this is wild knowledge. And if you do the opinion mining from the reviews or blogs, recently it's very popular among young people. So these are the conversations you can do with these kind of people. But he's very smart. What kind of tech? Yeah. So we need lots of technology in order to make it. Okay. So you have to understand language. You have to have a conversation, and you have to recognize image and video, and understand the customers and master his product. This is a big data kind of stuff. And the semantic. You have to have a word knowledge. And in general, this is artificial intelligence. So we want to create this guy, artificial intelligence for the shopping domain. That's our goal. Situation adaptation, manipulate knowledge, or think or inference. So these are the technologies, and also, of course, friendly smile. So interface is very important. And also for the future, you have to remember what happens with this car. So this is another big data. So creating this guy is our goal. Get it? Yep. Okay, so this is our goal, and I'm gonna introduce several projects. We already explained 2 projects, but I'm going to describe maybe 2 or 3 projects for now. So one is about the Rakuten Hub category. So as you know, that the Rakuten is expanding to the world. Right now, we are operating in 12 countries, marketplaces. And we want to connect it in the future. No. You know that Amazon has already connected a little bit. And eBay, you can buy anything from other countries. But we want to do the same thing on Rakuten. But as you know that Rakuten bought lots of different marketplaces, so the history is different. For example, the German market, they create their own categories or their own system. So migrating German information into Rakuten is not easy, and there are 12 of them. So, and one of the difficulty is about the category. The category is completely different. For example, in France, there are only 140 categories. In America, there are about, I think, 1,200 categories. In Japan, we have 40,000 categories. Completely different, how we can handle it. So solution we are thinking right now is that we are going to create a hub. Hub is actually the jiku of the tire no jiku hub. And we want to connect it to different marketplaces. But this is not easy because we have so many categories in Japan, etc., and the culture are different, etc. So designing hub category itself is quite difficult. And one of the difficulties is globalization and the locality. So we want to organize globally. Everybody in the different countries want to understand. We want to make everybody in different country understand the category. But of course, it's depending on culture. So something is local, so we have to adapt for the local. Then, actually, we look at all the 12 categories, and Google category, Amazon category, etc., and we understand, for example, like sports equipment exists in every categories. This is very common. So this is global. Everybody understands sports equipment. But baseball is popular in Japan, US, Thailand, etc., Taiwan, and Korea only. And for example, pelota, which is similar to baseball, but it's only very famous in Spain and France. So this is local, and this is global. So we can set a line between these two, and let's make this global knowledge as global into the hub, and this local information can be handled differently. So that's our solution. So we are creating this kind of information. So this part is global. So this actually we created 135 categories, which is common in the world. And everything else, like baseball, pelota, etc., will be handled by attribute value, so that you can add more values. So if we Rakuten go to Africa in the future, we can just add another kind of sports on this column. And then this is a local hierarchy. So each marketplace can design their hierarchy by themselves. And we handle this by just mapping from this table, this hub, to the locals. So that's our work right now. So it's like an ontology mapping, ontology design. And this is 135 categories we are designing now. And this is, of course, definition of attributes. And we are creating mapping tool, etc., so that we can help each local market to find the right category. Okay, so that's one topic we are working on. And next one is category correction. Okay. As I said, that there are 40,000 categories in Japan, in Japan. So Mapra, for example, looking at the Mapra category, you find this. This is actually happening. And unfortunately, there are many noise like this. Maybe you experienced it. So this is not good. This is not good for the user, and this is not good for merchant because you cannot sell Tengubai in muffler category. So we try to fix this. Okay, and how to fix this? This is also published as a paper. This is something machine learning or algorithm, but I will skip as much as possible. So how we solve this problem is that you know, the Tengubai, many Japanese people may know that the Tengubai is sake. This is common sense. We have to create this common sense. That's a solution we are doing. And how to create this? If we know the information retrieval research that this is for the TF-IDF technology. So if there is no noise, Tengubai product must exist only on the sake category. So that then you can see that if there's a keyword Tengubai, then it must be sake. But because there's a noise, so TF-IDF doesn't work so well. And we have to look at the data. Then we found that the merchant which makes the noise is limited. Not everybody making noise, only several merchants. So maybe we better to identify the bad merchant first. Then we can clean up the data and we can find the noise. So that kind of strategy we are developing. And the happy thing about this is that we fixed this noise in 2011 for the two big merchants at the beginning, and the sales went up a lot. So it makes these merchants happy. Actually, we received email from these merchants, and we report this to Mikita-san, and he was very happy too. Then, yeah, because this is so well done, we expanded this to the different merchants on the same category. And from this, at the beginning, of course, we don't know if this is going to be successful or not. So we asked the merchant, we connect with merchant and ask the permission, etc. But because this is so successful, after this, we didn't really ask the permission. We asked the permission, but we didn't really give them the data, etc. We just fixed it. So there was a requirement from the business people that the accuracy must be more than 95%. But actually the accuracy was 98.8%, and we got only one claim that the correct product was corrected in the wrong category. But it was only one, so that's make us happy. And we fix all the products in all the category. So hopefully, when you look at Rakuten Ichiba right now, you find less noise than before. Okay, and the last one is self shopping. So online shopping, when you compare online shopping and offline shopping, it's like this. So online shopping, you have a keywords, and you have a list of products. So it's more like search oriented. Or maybe in the category, you browse this, and you have a list of tomato ketchup or something. But offline shopping is like this. You go to the supermarket and look at the different product, and you may buy something you are not expected to buy. So it's fun, and this is convenient, right? So we want to combine these fun and convenient and provide some exciting shopping experience. And in Rakuten, there is some kind of fun page, like a ranking page. In the ranking page, it shows the most sold product in the category in the last week. And you can see first, second, third, and looking at this is fun. Actually, reading the description, etc., it's really fun. Or maybe the recommendation, like the person who bought this also bought this kind of recommendation. But for the cheese, recommendation are different kinds of cheese. For the cheese ranking, you have a cheese, lots of cheese. And actually, in Amazon, it's similar. If you go to cheese, they recommend cheese. Yeah, but if you bought cheese, what do you want to be recommended?
Wine.
Thank you. Yeah, wine or cracker, or maybe a cheese knife, pasta, salad, pizza, grater, cheesecake, etc. Right? So we want to find this kind of knowledge. And how we find this? How we create this knowledge? Actually, we have 100 million products, and each of them has a description. And merchant really write what we want to know. In the first sentence, for example, this cheese might work better with that wine. Or cheese variety from mild to full flavors, a number of wine variety may work with the cheese. Or tips for pairing wine with cheese. So we can infer that cheese and wine have some relationship, association between them. So we use a technology called LDA, not explaining, but and then we can find the co-occurrence and we can group them. Then we find that, for example, cheese and bread and jam and butter and milk are related to each other. Or pasta sauce or cheese, sauce, pasta, ready-made are related to cheese, etc. And you can click this and you can find something related to jam again. And this can keep continue. So this is fun actually. And so we have developed this kind of knowledge, and this is going to be applied at the some part of Rakuten Ichiba in the future. Okay, so our goal is we are trying to create the technologies for happy shopping experience, not the vending machine. Okay, go back to that guy. And that's what I want to say. And so we are hiring. So Rakuten Technology is hiring in Tokyo and New York. Right now there are 30 people in Tokyo and 10 also in New York. But if you're interested in joining us, please send email to this or any email address you find, and please connect with me. Okay. And maybe lastly, I created a video which is targeting to the user, to the general audience. So maybe we have 5 minutes. So let's enjoy this video.
This is Matthew from RIT, Rakuten Institute. Let's start with the story. It's been very successful.
Can you listen? No? No. Okay, maybe I cannot just say something. Yeah. Microphone?
Assault in France.
I think you can get the idea from the video.
Brazilians can buy golf clubs also from the USA.
And in the near future, cachaça could be sold in China.
And more and more. The more we make our customers happy,
The happier we are too.
however, there are challenges to be tackled.
The first one is
Language. We want customers from all over the world, so it's crucial to overcome the language barrier.
as in the story, the Tower of Babel can only be completed once we all understand each other.
The Rakuten Institute of Technology has world-level experts in machine translation technology to solve this. We tackle complex translation problems specific to the e-commerce domain. We're developing technologies that produce natural-sounding, high-coverage results, so your products can be understood all over the world.
Our goal is to say obrigado in 50 languages.
Problem number 2 is about
Categories. We have many markets, and each market has its own category hierarchy. In order to link these markets, we must link their categories too.
Of course, we want to find sausages from Germany in the sausage category in the Japanese marketplace.
RIT is creating Rakuten Hub category system so that the transfer of products between these different categories gets easier.
RIT is also creating an automatic category suggestion system to suggest the appropriate categories for a given product.
So, using this technology, the merchants can easily register their products. This can save you lots of time and help customers find your products much more easily.
Let's take an example to help explain this. In the Rakuten family, there are so many different categories.
However, it is very hard to find the right category in the different markets because the category structures are different. Those categories were created based on different culture, different history, and by different people.
So now, we introduce the Rakuten Hub Category System, or RHC.
It's basically a hub of different categories from different markets. Using RHC, we can now link all the markets.
For example, a watch from France can be easily delivered.
To anywhere in the world through RHC.
And cachaça can be delivered
To anywhere in the world through RHC. So, by solving these challenges, we can really link the world.
Now, we can make this Chinese girl happy by bringing cachaça from Brazil to China. A real happy ending to our story.
How does this work?
We're researchers at the Rakuten Institute of Technology, and we're creating state-of-the-art technologies.
Rakuten Institute of Technology is the research laboratory of Rakuten. It has 30 members with many PhDs.
We're tackling various challenges, including language, data mining, image processing, interfaces, infrastructure, and so on.
All of our research and development is conducted in order to see more smiles,
So, RIT is working on these challenges.
to empower you and our customers.
Thank you.
Actually, this video was created by our members, and the narrators are researchers. I think they did a good job. And you found that this is talking about the Brazil a lot, so I used this at the Brazil's conference. Sorry about that. Okay, and of course I mentioned 3 technologies, and there were 2 presentations before, but we have been doing the different things, including translation and automatic category suggestion and other things. So well, you can talk to me after this session, etc. But if you have some questions, including the question to the first 2 speakers, please please now.
Thank you very much. I heard a lot about the product, the category about in the product side. So, and you use a lot of features from merchandise description for the product. So I want to ask, do you think about using the user's experience log? So maybe the different countries' users maybe have the different kind of categories. So it's from the user.
Yeah. thank you very much. Oh, that's a good question. So yeah, user is very, very important, and the design of the category has to be done for the user. So we actually have lots of reviews, for example. Yeah, in Japan, I think there are 40 million reviews, etc. So we are analyzing this, and or other efforts that we want to take into account the user's point of view. Yeah. Thank you. Nice suggestion.
Thank you for the great presentation. I wanted to ask you, how do you see the future of commerce? Do you think that it will stay like independent, like now with the websites of Rakuten, Amazon, or eBay, or you think it will merge with other industries like entertainment or fashion, or just my question is, will it stay isolated like it's now? If you want to buy something, you go to the Rakuten website and you buy it. Or you think it will integrate in other containers of information?
Thank you. Yeah. Oh, that's a good question. Yeah, it has to be. Yeah, it's like the real marketplace. If you go to the department store, it's not just buying something. It's entertainment. It's you can talk, and you can see, you can have a game, etc. So it must happen in the internet as well. So it's not the Rakuten shouldn't be just find product and buy, but it should be connected with other entertainment. Great, thank you.
Thank you much. Is there any question? If not, we're supposed to bring our session to an end, and a big applause again. Thank you very much.